So if you haven't done so already, you'll want to watch the previous video that introduced this idea of composition of functions. It'll make the rest of what we're going to talk about with these next couple of videos. It'll help make those make a lot more sense. Okay, so let's look at this first example. It says the Lemons car dealership offers two incentives to car buyers. They give a 12% discount off the $33,000 sticker price of a new car, as well as a $2,000 rebate for an end-of-the-year clearance. If you were given a choice, which incentive would you take first? Or would it matter? Well, they've already given us the two functions we're going to be using. They've given those to us for us here. But I want to talk about them for a second. Now, the first one is obvious, where we have R representing the rebate. We're going to get a rebate of $2,000. So it'll be whatever the price is minus $2,000. That makes sense. But let's look at the second one, where it says D of X representing the discount equals 0.88 or 0.88x. Where do they get the 0.88 from? Look at the problem. The original problem talks about a 12% discount. There's nothing wrong with this function, but it is super important to understand how they came up with 0.88x. Think about it. A 12% discount represents what you're not going to pay for. This function represents the price of the car after the discount. So if we're saving 12%, what we're spending, what the price is going to be what's left over, the 88%. I used to get hung up on that all the time. Don't make that mistake. Anytime you're dealing with percents, I always think about what that percent represents. In this case, the 12% represents what you're saving, not what you're spending. Our function is going to be written so it represents what we're going to spend. So we're going to spend the rest, which would be the 88%, so that's why it's got the 0.88x. Okay, so these are our two functions. Now let's look at what they're asking us to do with them. It says write an equation for P of x, so P represents the price, equals R following D of x. In other words, the price P of x, if the discount is taken first, then the rebate. So the way we're going to do that is, first off, remember we talked about this in the previous video. When it's written like this means that we're going to find out what D of x is first and take that value and put that inside of function R. Well, we know that D of x is 0.88x. To maybe simplify things, let's look back at the function machine. Okay, so here's our two machines representing the composition of functions. So in this first function, this is D of x, this is 0.88x. Our second function is x minus 2,000. This one's a little bit more complicated than those problems we were looking at in the first video, because here we don't have a number we're putting in right away. They're just asking us to write an equation. They're not asking us to find a value. So the equation for this first one is going to be, if I put x into function d, what am I going to get as my answer? Well, when I put x inside, if you remember, this is my input. If I input x in for x, it's going to stay 0.88x. Now if I put that into the second function, I'm going to replace x with 0.88x. When I do that, I get 0.88x minus 2,000. That's my answer. Now, to save some time of always having to write a function machine, let's look back at what we have over here. What I was going to get at earlier was that if we take function d of x, which is 0.88x, we're going to put that inside of function r. So I'm going to replace this x with the 0.88x. So when I do that, like we said, r of d of x is going to equal 0.88x minus 2,000. So sometimes using a function machine simplifies things a little bit, gives you a visual, but obviously it takes a little longer to sketch that all out. So if you look at it this way, it makes things a little easier. Okay, let's look at the next part of this question. It says, write an equation for Q of x equals D following R of x. That is, the price of the rebate is taken first, then the discount. Instead of having to write a function machine, let's look at it the way we did the second time. We're going to take function R and put it inside of function D. So I'm going to take function R, which is x minus 2,000, and put that inside of function D. Now be careful here, because we have to take 0.88 times whatever x is, and this time x is this whole quantity, x minus 2,000. So it's going to be 0.88 times a quantity, x minus 2,000, which we want to simplify. When I distribute the 0.88 through, I end up getting 0.88x minus 1,760. So now the third part says, well, which would give you the better deal? Well, let's compare these two functions. If you notice, both of them start out by taking 0.88 times whatever x is. But in the first one, we're going to be saving 2,000 after that. With the second one, it ends up being that we save $1,760. So which would give the buyer a better deal? It would be the first one. And that was where the discount was taken first. And if they ask you in your homework assignment, if they ask you a problem like this, sometimes they say how much more would you save. With this one, if you notice, here you're saving $2,000, here you're saving $1,760. So you save $240. Now what I want you guys to do, here's a similar problem. I want you guys to pause this video. I want you guys to work this one out on your own. And when you get finished, play it and see if you got it correct. Okay, so you should have done the work, so let's see what you should have gotten. With this first equation, it says, originally it says, suppose the rebate is $1,500 and the discount is 22%. Again, they gave us the two functions, but if they hadn't given it to us, remember the discount, the 22% discount, that represents what you're saving, so what you're spending is 78%, or 0.78. And remember, we never use percents when we write them as an equation. We always change them to a decimal by dividing by 100 and move the decimal over 2 places to the left. So for this particular problem, you should have gotten as your answer as R following d of x ends up being 0.78x minus 1,500. For the second part, for d following r of x, where the rebate is taken first, you should have gotten, after distributing, you should get 0.78x minus 1,170. And if you have the question of, do you have to distribute? Yes, you always want to distribute to simplify your equation. And which would give the buyer a better deal? Obviously, taking the discount first. Again, gives the buyer a better deal. This time, you save $330. Okay, that's this first example. Watch the following videos for more examples.